Hello, hope you're doing well. Having a brilliant day. Happy Monday. It's Monday where I am, but happy whatever day of the week it is wherever you are. It happens to be a bank holiday in the UK, so I think it is in the US as well. So double bubble on that, an extra long weekend. So it's become quite obvious to me, the more and more people I speak to, the more and more people don't necessarily understand the ramifications and consequences of cost. Now, it used to be very simple in terms of using large language models. So I want to do a little demonstration of cost and talk you through some of the consequences of your decisions about cost. And then I want to talk about some of the paradigms that come in, like prompt caching, and explain the stateless nature of these conversations, and why you might want to adopt strategies if you want to use micro models or local models for very low cost output for certain types of tasks, of which I'm interested in a lot, but development is a great example. Local models particularly, you can use them with some IDEs with Klein, and I was using a few capabilities this week with people that created UIs that supported local models, but because they're kind of built to rely on a large context, local models generally aren't very good at that. You need to consider how you consume micro or local models for how they work. So, for example, a very common misconception in Alarma is the default context length is 2048. So if you use sort of Alarma in its base configuration without changing that, then you're going to end up with some very poor outcomes, because it's going to remember very little about the conversation that you're having. Now, you can increase that, so you can do that either by cloning the model and setting the number of parameters in a cloned version of the model by editing the model file before you create it, or you can set it per API request as you make requests if you're using the API to Alarma to be able to do that. But generally, you have to take some kind of action to do that. On a consumer graphics card, depending on how powerful your card is, you might be struggling to get higher than 8192 or up to maybe 32,768 tokens, because input tokens are very expensive. So that memory of input tokens is very much more expensive than the number of parameters in the model. So you may have a model that uses 8 gigabytes, but you may find that if you go to 4096 as a context window size, your card is pretty much maxed out if you're using a 12 gigabyte card, for example. So you very much have to bear that in mind with local models, and that's why with local models you generally try and avoid long conversations. Using local models is a good strategy, and DeepSeek taught us that actually if you use a much lesser capability in their case because they didn't have access to the latest hardware, for example, then you have to be more innovative in your consumption to be able to produce results which are of the level of people who are doing things in a much more expensive fashion. And then a lot of innovation came out in the paper from DeepSeek, lots of different innovations with a mixture of experts and all kinds of things in there. And I've done a post on that before, so I won't bother discussing that today. So first of all, let's talk about costs. So the key mistake many people make is, there's a new model out, I'm going to use the new model because it's the best model. A lot of these models over the past year are very capable now. So really, do you require the capabilities of a particular model to be able to do something? So that is a very important requirement, because let's have a look at some of the costings. For this demo, I'm going to use GPT-4o Mini, and I'm also going to use O1. So let's have a look at the costings for that before we start. So give me a second. So we're going to use GPT-4o Mini. It's quite a capable little model, and the cost is, this is per million tokens, $0.15 input, $0.6 output, and then we're also going to use O1, which is basically 100 times more expensive. Now, to add to the mix now, from the end of last year, the concept of prompt caching came in. So essentially, this is a concept where essentially it's not caching the text that you send it, it's caching the transformational compute of the text you send it, and it's generally using the text you send and quite often a hash to determine whether it's got something in the cache that it can use without having to go through all that transformer computation again. So that has two major impacts: latency, so depending on your provider, 80%, 90% faster for bigger conversations. Should you be using big conversation in the first place? That's a question. But then, of course, in this case, you can see that in both cases that the cost is 50% cheaper. So has a big impact. Now, all the providers support this now. I'm going to talk about OpenAI just because it's a little bit easier. It's kind of there, implicit out the box. With Claude, you can do it by setting the cache control and using what they call ephemeral cache on the request to be able to instigate prompt caching. With Google Gemini, it used to be you had to define an explicit cache, and I think from about May the 8th, they've now supported an implicit cache model, and they still support the explicit cache model as well. So I don't want to go into too many complexities about the different models, but it's very important you consider cost, right? Cost. So there's a times 100 factor difference here. So if somebody gave you £1,000 or somebody gave you £100,000 and you could get the same results, would you quite happily throw £99,000 out the window? I know I wouldn't. So you've got to be very careful because these costings at high volumes can add up quite quickly. So, it's a massive difference you can make via optimizations. So the first optimization you can make is pick a model that's capable enough to do the tasks that you need to do. And you can do this kind of as part of an agentic workflow by using a lesser capable model first, using reflection to determine whether the answer was good. If it wasn't good enough, then you can escalate it to a more expensive model. And you may find then that probably 9 out of 10 things you do, you might get away with using the 100 times cheaper model, and one time you might want to escalate it for 100 times the cost. And you work out the percentages there, you're making a massive cost saving there anyway. You need to be very careful about how you work out about cost. I remember somebody once saying to me, I like to treat my employers' money like my money. And I also like to treat my money like my money. So I think you should really, a lot of people don't really put enough effort into leveraging what they require for a particular task, bearing in mind the impact it's going to have not only on your wallet, but it has an impact on the environment as well, because you're using a lot more GPU compute. That's where the cost comes from. It's not coming from, oh, this model's better. It costs a lot more in terms of GPU compute time. So that's the first thing we've got to bear in mind. So let's just consider OpenAI because that's simpler. So we'll do a demonstration where we use GPT-4o Mini and we use O1. O1 is also a reasoning model as well, and I'll talk more about that later on, about the impact of that. Let's not confuse ourselves at the moment with what we're talking about in terms of calculations. But they both support cached inputs. So the best way to do this is to create a demonstration. I've knocked together a quick half-an-hour demonstration of a two-way chat console with a very simple system prompt to tell it that's the mode we're operating in. And we'll go through this demonstration and then we'll show you how caching works. So in terms of OpenAI, the cache only clicks in at about 1,024 tokens. And then subsequent to that, there are 128 token boundaries, thresholds, before it'll basically add things to the cache or pull things back from the cache and then use them to obviously save computational time, latency and cost. The latency impact is a lot higher than the cost, and I suspect this actually saves the providers a lot more money than it does in terms of using the latency. Now, the latency is, if you're having a long-running conversation, is partly, do you really need to have that long-run conversation? And that's another thing that some people don't understand. I think people are getting better understanding it now, but model calls are stateless. So generally, you'll have a system message, system prompt. That's one message. You'll then type a message, which is generally called a user message, and then an assistant message will respond back from the model. So just writing one question, you've got 3 messages. You might then go on and add another message, and another message will come back, and you're up to 5, and it goes up in steps of 2. So over time, each time you send a request, you have to send the whole request again, and the model starts from scratch, unless it's using caching. So before caching, basically everything was reprocessed each time, and you were charged each time for the input, including the input you originally sent, and all the input for the second request you make, and all the input for 1 and 2 for the third request you made. So very quickly this snowballs into quite an expensive cost to you on your bill, and it can be quite often hard to sometimes figure this out. So once you hit caching on these models, you see you get a 50% discount. So the way it works is you still have some new input tokens which aren't in the cache. You have some cache tokens. You get the discount on the cache tokens, and then basically subtracting the number of cache tokens from the total number of input tokens to leave the difference between the two. You pay at the full input token cost. So the best way to see that is through a demonstration. I hope your head's not starting to hurt. Mine is slightly, but that's just the way I was born. So let's have a look at this. So here we've got this simple agent. It's using my agentic network to basically fire up this thing. And what we've done is we've built in some capabilities to do costing. So if you're using the sort of streaming version of the API calls in OpenAI, you don't get the usage metrics back in terms of tokens. But if you're using the non-streaming version, you do. So we'll use that for this demonstration. So first of all, let's see if it's alive. Hello, that's always a good start. So you can see the number of input tokens there was 73. Why was it 73? Well, behind the scenes is a very short system prompt that's telling it what mode we're operating in. So that is part of the payload for the number of input tokens that the model sees. And as you can see, generated 9 output tokens. The total is 82. The number of messages in the conversation is 3. System prompt, user message, assistant message. Now you can see here we've also got figures for caching and reasoning. So we've got cache tokens. We've not hit the cache limit yet, so we're not going to have any caching benefits. 0. It's not a reasoning model, so we're not going to see any reasoning tokens ever. Now, a reasoning model, you can use chain of thought, and I've used it for a long time before it was even available in models. You can use it outside of inference, and you get a lot better results with less capable models by doing that, because you can break things down into smaller tasks and you can use these models. You can get a lot of efficiency out of micro models now and out of local models if you use the right engineering practices to be able to do it. If you don't, you won't get very far at all, and you'll just say they're rubbish. And that's probably more your failing than their failing. These are all very capable models now, and you need to just think about what you're doing. A, how you engineer it. B, about the cost. And cost is key, because very quickly over time, these costs are going to build, and they can be quite hard to track. So you need to understand these basic conventions that are happening now, and they'll probably change over time as well. Who knows what's going to happen? It literally is changing all the time. Every week, there are changes on pricing in terms of new paradigms or how caching works with one provider or another provider, new models. So you need to keep up to date on how these things work. So what we've got here, so we've got these little calculators. So we'll have a cost of each question, and we'll have the cost of the conversation. So you can see for the first question, they're the same. So we've got the number of input tokens, base input minus cache. There are no cache tokens at the moment. When we get to cache tokens, we'll take those away from the number of input tokens and just create the true input token cost. And then we have a second figure for the number of output tokens and the cost. Output tokens are generally a lot more expensive. And then we've got the cached token cost. There are no cache tokens at the moment, so it's 0. But as we build up a very long conversation, you'll see that will have an impact on the total cost. So we've started off here with a very simple prompt. So let's go away and get it to create some more content. So let's get it to tell me a story. Let's hope it's an entertaining one. I could do with a bit of a laugh. So that is, again, it's not streaming here, so we have to wait for the full request to come back so we can retrieve the statistics. So you can see now that the input tokens were 94. So that was the original set of tokens from the previous request, because we have to send the whole thing again because it's stateless, plus a few more tokens for the very little input that I asked, which was tell me a story. So here we can see now that we've got 442 output tokens, which is the majority of the story. We're up to 5 messages now because I've had another user and another assistant message. We've still not hit the cache, so we've got no cache benefit. There are no reasoning tokens on this model because it's not a reasoning model. We'll use O1 in a minute, which is a reasoning model, and I'll talk about the impacts there of what reasoning has on costs as well. So again, you can see obviously that was quite a large jump for that particular message because the size is increasing quite a lot, and there are a lot of output tokens in that response, and the output tokens are 4 times more expensive. But it's 100 times less expensive than O1. And it's a lot more expensive than running it on a local model, which is almost free for the few hundred watts an hour you use in terms of electrons. And again, I'll talk at the end a little bit about why I'm so focused on avoiding long conversations and leveraging micro or local models. And the reason I do that is not because I necessarily want to use local models. I love the cloud models, but it encourages you to adopt engineering strategies that make you mega efficient. If you can make something work on a local model, you're going to save yourself a fortune, and it's all about cost. So there we go. So now we need to hit the cache. So let's go and get it to do something else. So let's get it to add another chapter to the story. Lila and the spirit, very exciting. So it's created chapter 2, very good. Maybe we'll publish this and we'll have a little side gig and make a bit of money. So we're now up to a total number of tokens of 1268. We haven't got any cache tokens yet. We'll probably see if we add another chapter now. This will have been persisted now and gone over the cache threshold, so it'll be persisted in the cache. So next time we make a request, it'll be over 1,024 tokens, and we'll get a cache benefit from it. So how do we get a bigger response now? We'll have another chapter. Such an exciting story. So off we go. Add another chapter to the story. I'm guessing this is going to be chapter 3. I mean, who knows? If this is chapter 3, I'm going to buy a Euro Millions ticket this week. I could be in. So it's going away, generating a response. And you can see we're up to 1/10 of a cent, just over 1/10 of a cent in terms of the conversational total cost. If we were using 0.1, then it would be 100 times more expensive than that. I was thinking about this one, so this should be entertaining. Again, this is a little bit sort of based on the provider's load in terms of the response time. This is a little bit long, but it'll come back at some point, I'm sure. I don't think this is all down to the size of the a mega chapter. Oh, we have got a chapter there. It is chapter 3. Damn, I completely missed it. Okay, so here we go. So we've now crossed the threshold for input tokens. We've only just crossed the threshold. So you can see we've not got any cache tokens, and we've not got any reasoning tokens because it's not a reasoning model. So let's go and add another chapter, and then we should see some cache tokens. Add another chapter. I've obviously got these set up on the stream deck, so I don't have to type them. Makes it a little bit easier for me. Chapter 4. There we go. So now you can see we've actually crossed the cached threshold. So out of that, 2 to the power something is a great number. You see it everywhere. So the number of cache tokens was basically 2048, which is a power of 2, strangely enough. And the total number of input tokens, 2151. So our actual cost there, we've got a cache cost, which comes at the 50% discount. And then we've got the input tokens, which is 103 input tokens above and beyond what the cache was. So we've paid for 103 input tokens at the full price, and we've paid for 2048 cache tokens at the 50% discount price. So that's kind of how that works. If we add another chapter, you'll see a similar thing kind of happening. So I'm guessing this is going to be chapter 5 now. I'll make sure I keep an eye on the screen this time so I don't miss it actually generating it. It's kind of, they all seem to be about the same size, so I almost missed, I think on chapter 3 that the screen had changed. Off it goes. So chapter 5, genius. Lila's having a very exciting time. So you can see now again, we've gone through here, and we've got 2,944 cache tokens. We've got 2,944 cache tokens, 2,994 total tokens. So our number of input tokens we paid for there were 50, and the rest were paid at the cache cost. And now we're up to about 0.3 of a cent. So again, that's kind of, if we were running 0.1 at this point, we would be at $0.3. So you can see a big difference it's made. So what should we do now? So let's have a look at 0.1 and do a similar thing. So let's clear the cache. So the cache is cleared, it's a new conversation, all the costs are reset, and we'll switch to 0.1. So we're now using 0.1. So first of all, we'll just check it's there, always a good start. So there we go. So you can see here that we're already close to the cost of that very long conversation that we had previously, just by saying hello and it responding. There is no caching here. Now this is a reasoning model, right? So this is a reasoning model, but we didn't get charged for any reasoning tokens because the model didn't need to reason for that particular task that we set it. So when you're using thinking models, even though you may not see it in the output, you're paying for the inference of those. So there is a cost to those. And with OpenAI, generally, that is kind of masked. But let's ask it a question that should hopefully trick it into going into a reasoning mode. So say a little problem, and we've kind of suggested to it that it uses reasoning to get to the solution. So you can see here that as part of that, that we had 256 reasoning tokens, and the output was 453. Now, the actual total there, the way you work it out is, let's take what was the response. because that won't be, oh my goodness, that won't be 453. And let's use, they haven't got one for O1, but they've got one for a tokenizer cost estimation calculator on the OpenAI website. This will be close enough. So it's just the token count. It's nothing to do with cost. So let's estimate the number of tokens in there. So that says there's about 170 tokens. Now, it's not exactly necessarily the same as what you get with O1, so the different models might be slightly different. So actually, I completely forgot. How many tokens did that say? That said 170. Well done. So we had 170 tokens, but what we didn't see was the 256 tokens that were being used for it to plan out its plan of attack, its chain of thought, before actually defining and setting on the task for the answer. Chain of thought generally is a good strategy for models to get them to focus on a plan, to be able to do something, to then go away and come out with a better outcome. And this is in inference chain of thought. I've used it since before people were using it out of inference, and I still use it a lot, and I'll talk about that shortly. So that 256 plus 170 takes you close to the outputs that we got there. So that's based on the fact that it wasn't necessarily a precise calculation from the OpenAI tokenizer. So basically you're paying for the reasoning tokens you don't see, plus the output tokens you do see. So let's go away and let's go and get it to ask a story, and we should see the same thing that caching or kick in, create a story, sorry. So let's go away and do that. So we'll get it to tell me a story. If it's got Lila in it, okay, it hasn't. That's good. It's got my in it. That's brilliant. So we're now still not using any. We still used. It actually used a few reasoning tokens there. It didn't think a lot about what it was doing. Clearly, the majority of those are output tokens. So let's go and get it to add another chapter, and let's get to the point where we trigger caching, so that we can see the cache kick in by getting the 50% discount on, and the 50% discount on O1 prices is significant, because instead of paying $15, you're paying $7.5. So that's a big change. Whereas before, it was a much smaller change because the base cost was a lot smaller. So let's go away and add another chapter until we hit caching. Chapter 3 in progress. A bit more thought went into that one. We've still not hit the cache yet. I think on the next request we will, and then you'll see we've gone over the threshold, but we've gone over the threshold on the last request, which means at that point it may have cached stuff to be able to trigger when we make the next request. So we'll probably see caching kick in here. Add another chapter. I'm guessing chapter 4, but you can see we've already spent $0.2 at this point because we're sending the whole thing again. We haven't hit caching. It's very expensive. It's already, 100 times the cost of what we did with the GPT-4o mini model, and we've only got a fraction of the way into the same sort of workflow that we did with that. So it's not only it has a massive impact, not only the multiplier, but on the cost for you to get there. So here you go. So we've hit caching. So we can see we actually got, and the caching probably works differently on O1. I haven't researched it too much. It looks like it's using bigger, wider boundaries here, because it only cached 1,408 tokens, and there were 553 input tokens at the full price. But you can see it obviously makes a big difference on cost in terms of that much less number of tokens with nearly the same cost as the cache token cost. So again, this is transparent to you in OpenAI. It's less transparent necessarily in Claude, and it's now becoming implicit in Gemini 2.5 onwards. So you've got to keep up on this. You've got to keep your costs under control. So the point really I'm trying to make here is, do you really need to have long conversations? So probably what I'm going to do in the near future is I'm going to actually, I've been waiting for autonomous AI to be coming out in terms of this week's been very big for that. So you've had Codex, you've had Microsoft doing it with GitHub Copilot agents. You've had Google doing it. I've been using autonomous agents for developing AI capabilities for doing development for quite a significant time. But once you've got an agentic network, I'll do a demonstration where in 100 lines of code, I can develop an autonomous system that can write code. Not only can it write code, it can check the dependencies, it can install the dependencies, it can run the code, it can reflect on the code, it can react to issues. And we can do that probably in under 100 lines of code. Now, I can do that, and I'll do that using micro models or smaller models. So GPT-4o Mini is a great one, or I may even use local models. And the way I get away with that strategy, and that's why you won't see it so successful in things like Microsoft's Magenta UI AI thing that came out recently, or things like Klein. When you're using them, they tend to fall apart because they're actually relying on a big context. And as I said, out the box, and a lot of users don't realize it, they're using a llama with 2048 tokens, so it won't work on anything. So unless you use the strategies to either clone the model and increase the number of the context size, and you have enough context capability on the GPU you're running, or you make that as an addition to the request. Each time you're making a request to the llama API, you're not even going to be getting 2048 tokens, so those can't possibly work. But what you can do with micro models and large language models, you can actually do the chain of thought or the plan outside of a long conversation. You can go away and have an agent that's basically dedicated to planning. It'll break it down into a large set of tasks, so it may break it down into 10 tasks. Those will be 10 individual conversations that will then happen. Each may have a reflection step behind it, very small reflection step. So each of these are tiny requests, which means you can leverage small models at very, very low cost. You're not being charged for sending massive conversations that build up and build up and build up and become more expensive, even with the discount that you're getting with prompt caching. So actually very much about leveraging these models is very much about how you engineer your system to get the best out of them. So the key one is you can save times 100 by using a model which may give you the same result if you research whether it's capable enough. On top of that, if you break it down into smaller tasks, you can probably get another 10 times multiplier. So very easily, you can save yourself 1,000 times potentially in terms of if you're trying to, autonomous development won't necessarily work on local models because they don't have a massive cache unless you use another strategy. So instead of throwing $1 million out the window, you can just throw $1,000 out the window, and you can stick 999,999 pounds in your pocket. So I don't know who would prefer, if you had 2 piles of cash, would you take $1,000? Would you take $1 million? I know which one I'd take. I probably won't get offered either, but that's by the by. So really, I think it's just surprised me the number of people at all kinds of levels organisations that must be wasting a lot of money on models that they don't require for the tasks they require because they're not optimising. I've got to use Claude 4. I've got to use O1 because it's the best. Why is it the best? It's the best. They don't really understand how costing works. So even at, sort of levels in sort of meeting rooms and things, very quickly what will happen over time, and you'll see this kickback coming. My God, look at the costs. A bit like when cloud first came out. Look at the costs. I'm going to use this. I'm going to use that. Look at the costs. And very quickly, these costs can go out of control. So even if you're getting, a decent discount or something from a provider to get you on board, it's like crack cocaine. Your first one's free, then you got to pay for it. Over time, you can very quickly build it to very high costs. So really, that's all I wanted to talk to you about today. It's quite complicated to understand. You see very few people really explaining well how it's done. So I thought I'd spend a little bit of time putting together a little bit of a video so that you could understand how costs work. And the most obvious cost saving you can make is choose the least expensive model that gives the best result for the task you require. That's going to give you the orders of magnitude saving. Then you can get discounts of 50% plus on cost, and you can get discounts on latency of 8% or 9% on very long conversations. Should you be having the long conversation in the first place is the question you should ask yourself. And that's where a lot of people go wrong, is they just think, I'm doing this thing and I'm going to do this thing and I'm going to send more, I'm going to add more, I'm going to add more and add more until I finish the thing. They don't think about engineering to break the thing down into smaller things. So really, that's all I really wanted to get across to you today. So hopefully you found that useful. And it's a bank holiday. It's miserable because it's always miserable when it's a bank holiday in the UK. It's kind of how it works. But hopefully you've done something good with your day. Have a great day. Look after yourself. Take care. I'll speak to you soon. And bye-bye for now. Bye-bye.